Okay, Unit 1, Assignment 3, Office Hours. You should check your answers if you've not yet. So here are the answers. Hopefully you have checked them. Pause it if you need to. All right. Okay. So I'm going to go ahead and work these out. So, okay, a bunch of rational inequalities. So this is all one side compared to 0, one fraction. This one's very nice. We're ready to go. So we're going to do a line check. -3 has to be an open dot because it's in the denominator. It's vertical asymptote. That -2 is going to be solid because it's a 0. I'm going to test the value. X equals 0. Positive, positive is not negative. False, true, false. Answer is -3, -2. All right, next one. X equals 4, which has an even power on it. So that was not going to change sign there. So, let's see, open dot -3, open dot at 4. Keep track of that guy. It's going to bounce off the graph. Test X equals 5. Positive, positive, true. Stays true. False. The answer is -3 to 4. You have to break it up 4 because 4 is not a solution. If it were solid, you would just give one big answer. There we go. Next one, we could do a little bit of factoring on it. X equals 4, X equals 3. Oh, shoot. Got to bring everything on one side to equal 0. Doesn't make sense to do all that. Okay, least common denominator is going to be x minus 3, x minus 3. So we're going to get 2x minus 8 minus x plus 3 over x minus 3. So that's going to be x minus 5 over x minus 3. So x equals 5, x equals 3. Line check. Open dot at 3, solid dot at 5. Test x equals 6. Positive, positive, true, false, true. So -infinity to 3. Union bracket 5 to positive infinity. Let's see. Okay. All right. Number 4, move everything one side. Compared to 0, least common denominator. I'm going to combine into a single big fraction. So we get x squared minus x plus 2 over x minus 2. Leave the bottom factored. The top, x plus 2. Ooh, the top, I don't think we can factor that. So we got to use quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Gives you positive 1 plus or minus. This is going to be 1 minus 8 is -7. And so that's going to be imaginary. So we don't need those for a line check. They don't actually create x-intercepts, which is what our line checks are all about. So we just are going to use the ones on the bottom, x equals 0 and 2. Open dot 0, open dot 2, test the value, x equals 3. Positive, positive, false, true, false. Answer is 0 to 2. But I'd be looking for this work right here. I'm not thinking it's imaginary just in your head. So you gotta show the work and sure you get imaginary and just bail on it. Okay, move everything to one side. Least common denominator. Gotta distribute all this stuff. So we're gonna get x squared plus 2x minus x squared, and then you have 8x minus 8x, and you have 15 minus 15. And so the x squareds cancel, so we have negative 6x minus 15, combine like terms. Then we can factor negative 3 out if you want. So x equals negative 5, x equals negative 2, x equals negative 5 halves. Line check, negative 5 is an open dot. Negative 5 halves is negative 2.5. That's a solid dot. And negative 2 is an open dot. We're going to test x equals 0. And it's going to be negative, which is false, true, false, true. So the answer is negative infinity, negative 5. Union bracket, negative 5 halves, negative 2. That's your answer. All right. Last one of these. Move everything on one side. Convert to 0. These come denominator. This should be 6. So we get 6x minus x squared plus 5x. So we get a negative x squared plus 11x. Factor negative x out, get x minus 11. So x equals 5, x equals 0, x equals 11. Line check. So open dot at 0, open dot at 5, open dot 11. Test x equals 12. Positive, and then we end up with a negative, which is true, false, true, false. So final answer is parentheses 0 to 5 union 11 to positive infinity. There you go. So hopefully you guys are getting good at those. And then we talked about some new stuff, absolute value inequalities, and we're all about the rule of positive. The middle's at 3. We're going to go 1 away in both directions. It's going to be open dot at 4, open dot at 2, and it's everything more than 1 away. So going away from it. Negative infinity 2, 4 to positive infinity. So that's the quick way. Next one, we want 1 there first. So x minus 3 absolute value is still there. Middle is 3. We're going to go 6 in either direction to 9 and negative 3. And it's all distances less than 6 away, so it's got to be closer to the middle. Brackets. Okay, this one you can do it with multiple. Middle is negative 1. Go 2 away, 2 away, 3 away, 3 away. So solid dot, positive 1, solid dot at negative 3, solid dot at 2, solid dot at negative 4. Distance is more than 2 away, but less than 3 away is going to be these little chunks right here. Negative 4 to negative 3. Bracket, union, bracket, 1 to 2. There you go. Now, absolute value equations, you could square both sides. I wouldn't do it. I would just do the inside of one equals the inside of the other. And then solve that one. So x equals 12 is one of your answers. And then I do the inside of 1 equals the negative of the other, either one. You do this equals negative that, that equals negative that. It's going to be the same thing. And solve that one. There's really just two cases. So x equals negative 2/3. So the answers are x equals negative 2/3 and 12. Now, inequalities involving two absolute values, the best strategy, I think, is to square both sides, get rid of the absolute values. X squared plus 6x plus 9 is less than x squared minus 4x plus 4. You're going to solve it. It looks like polynomial inequality, so we probably want to get everything on the same side, but what you might notice very quickly is that it's a linear, because the squareds drop out. So I would just try and solve it like a linear inequality. And then interval notation, of course. Square both sides. 9x squared plus 6x plus 12x plus 4 less than or equal to x squared minus 8x plus 16. Now this one is a polynomial inequality, so we're going to want to move everything to one side compared to 0. So it's going to be 8x squared plus 20x minus 12 less than or equal to 0. Now I'm going to factor 4 out to make life a lot easier for whatever you do, factoring or quadratic formula or rational theorem, whatever. 2x and x. It's going to be a 3 and a 1. One's going to be negative. We want positive 5 in the middle. So I think we'll put the plus 3 here and the minus 1 there, because that would give you plus 6x minus 1x is 5x. So x equals 1/2 and x equals negative 3. We do a line check. These are solid dots. Negative 3, 1/2, test. X equals 1. Positive, positive, false, true, false. Negative 3 to 1/2 brackets. So there you go. That's it. You guys should be good at this stuff. And something new next.